Good morning, everyone, and welcome to our webinar on Cherwell Advanced Tuning. We're going to give folks just a couple more minutes here to finish dialing in. We have quite a few people joining, so if you'll hold the line for a moment, we'll begin shortly. Okay, good morning, everyone. We're going to go ahead and get going with our webinar. Thanks for joining us today. Our topic today for our Advanced Cherwell Practitioner Forum is going to be Cherwell Performance Tuning. Before we get going, since folks are still dialing in, I'll give a very brief overview of Stratacom, who we are, just for anyone who may be unfamiliar. Stratacom is an IT service management consulting company. We were founded in 1997, and we've specialized in a variety of the most popular ITSM solutions in the market since that time. Cherwell has been a specialty of ours for about the last 6 years or so, as it's rounded out its full ITSM suite and become one of the big players in the market. Stratacom focuses primarily on professional services. If you ever need assistance in the future with a variety of wish list items, enhancing Cherwell, upgrades, maps, build-outs, please reach out to us. We'd love to assist you. With that, we are going to go ahead and jump right into our presentation. The first section is going to be on Cherwell Performance Tuning. We have Eric Kruger, who is a senior consultant here at Stratacom, who will be leading through the topics. I would like to invite you to jump in with questions as you have them. You should see a questions pane. If you don't, find an orange box with a white arrow. If you click that, that will expand your panes, and you should see a section to answer questions. Everyone's going to remain on mute for the first section of our call as we go through the presentation, so this questions panel will be the best place to enter them, and I'll be happy to interrupt Eric with questions as we go. Once his presentation wraps, we're going to keep the lines open for open forum questions and answers. So if you have any burning questions, problems you can't solve, that'll be a great chance for you to ask the consultants we have on the line, but also the community that's on the line. We usually have quite a few people from the Cherwell community that are very advanced and have done cool things with Cherwell. So stick around for the end if you have questions, or if you'd just like to hear what interesting things people are doing with Cherwell. With that, I will turn it over to Eric, and we will get moving.
All right, thanks, Laura. You can. What do you see? I shared my screen, but I have two monitors, and
I see your intro title deck.
Okay.
So Cherwell Performance Tuning. So I think you're set.
All right. So our agenda today. Once again, my name's Eric Kruger. I'm with Stratacom. I've been with Stratacom since the beginning. So, and I do a lot of. In the past, I've done a lot of performance tuning. I've done a lot of high-level architecture for customers, and I've architected systems with up to 5,000 to 6,000 concurrent users. So huge, massive systems for some of the biggest companies in the world. So I know a lot about performance and database performance. I used to be a DBA in a previous life, so that's what we're going to talk about. So today, I'm just going to give a little performance overview. We'll talk about some of the Cherwell hardware requirements, application tuning. So these are things that you can actually do in Cherwell to make performance better, or things to avoid in Cherwell to not make performance worse. A little bit on IIS tuning, and then we'll dive into the Cherwell health check and how to read it and what to do with the Cherwell health check. And then a little bit on database maintenance tasks, and then I've got some other maintenance tasks in here that we'll kind of gloss over. So hopefully I've got a lot of information in here, a lot of really useful information. And normally when I do these performance tuning webinars, people will take my PowerPoint and kind of use it as a guide, because there are some very concrete things you can do in here. It's not step-by-step, but you can work with your DBA or your Cherwell administrator, or if you are a Cherwell administrator, you can do some of these things. And unfortunately, I have a lot of information, so I'm not going to spend a lot of time on any one thing or get very specific, because I want to cover that. But if you do have specific questions, feel free to ask them during the presentation. I'll try to answer them quickly, and we can kind of have a roundtable afterwards. All right, so a little bit on the performance overview. Cherwell CSM is primarily relying on the underlying database for performance. So when troubleshooting performance, almost always we're going to start looking at the database, horsepower of the database, queries, things like that. So 90% of the time, maybe even more, you're going to see that any performance issues you're seeing are database related. There's some things we'll talk about for application tuning, but you can pretty much, quote unquote, fix any issues by tuning the database or updating your database horsepower. So you can have a lot of, you can do a lot of maybe unorthodox or considered bad things in Cherwell. And if you've got enough database horsepower, you can pretty much ignore all that stuff. And a good database horsepower will fix a lot of bad decisions that you can make in query generation, or not adding indexes, or some other things that you can do in Cherwell. And this information is good for the portal, it's good for the web tier, it's good for the Windows client. There's very little difference between the clients and performance, at least dramatic performance. I mean, we're really just forms on top of a database. So that's where most of our performance gains are going to come from. All right, so let's talk a little bit about hardware requirements for Cherwell. They're pretty minimal. You know, if you're hosted, you don't really have to worry about this part. Cherwell will properly size your environment. If you're running internally, then you know, you probably worked with Cherwell. So Cherwell's, because it relies so much on the database, really hardware requirements are pretty low end. 4 cores and 16 gigs of RAM will work for most of the customers I've seen on Cherwell. Very large customer, so you've got 500 plus, or let's say 200 plus concurrent users. You may want to segregate background processes onto a different server. And you may want multiple Cherwell servers for failover and performance purposes. So this is just a little diagram that Cherwell provided with how you can break some of that out with an application server and like a Cherwell service server. And you've got your automation process server, your scheduling server, and your email monitor. So if you're a little bit larger, you might want to break those out and just get them off your application server. You may also want to have multiple application servers for failover purposes, or I mean, you can literally add, I mean, Cherwell will run, you could have 32 processors and a terabyte of RAM on a Cherwell server, and it'll run just fine, or you could break that up into multiple servers for failover and different things like that. So, but typically, you know, unless you're over 200 concurrent users, you're probably single server, maybe 2 for failover, and you're probably like 16, 24 gig of RAM or something like that, for maybe 6 or 8 processors if you've got a really active user base. But generally speaking, especially in regards to other products, this Cherwell does not use a lot of server resources. Database hardware. So if you're sizing your database, the bigger the better. I think our database server we use in our sandbox, I think I've got like 8 processors and like 64 gigs of RAM allocated to it. Typically RAM is your biggest thing. Your typical SQL server, you probably see 4 cores, 16 gigs of RAM. You know, if you're under that 200 level, the more memory, the better. So ideally, if you're not sharing your database server, if you're a single database server dedicated, you'd have enough RAM to cache your entire Cherwell database. So I'm seeing a lot of, we work with dozens and dozens of customers. We've got lots and lots of sandboxes for them. We get lots of customer dumps of their databases. Typical size that I'm seeing is like in that 25 to 50 gig range. So if you've got, say, 25 gig Cherwell database and you've got 32 gigs of RAM on your SQL server, chances are SQL server will be able to cache your entire database in RAM, which is the best case scenario. Obviously, if it can cache the entire database in RAM, you're going to have a lot better performance than if it's pulling things off disk. Disk storage, so this really depends on how many attachments you're storing. So typically, Cherwell storage requirements are very small, so except for attachments. Most of the databases I've seen come through our sandboxes are less than 50 gigabytes. So even fairly large customers with lots of attachments are going to be less than 50 gigabytes. Now, once again, if you're over that 200 user mark, you're probably bigger. But as far as sizing, if you're under that, 50 gig is a good place to start. You probably will run for years before you hit that. Put the fastest disk in as possible. Our internal database server configured the fastest SSD drives I could get on a RAID card, RAID 10. I think I've got 16 of them. It's really fast for reads, which is what you want. Possibly a little bit slow for writes on SSD, but when I've got 16 of them striped RAID 10, it's pretty quick. Ideally, you want to separate your data from your indexes and your rollback segments on separate disks if you can. We don't do that internally, but we don't have any production stuff either. So ours is all sandbox. So if you work with a DBA to separate your data indexes and rollback segments, if you're really big, you might even want to separate high use tables from low use tables, things like that. But typically your bottleneck in your database environment is going to be your disk. So even 16 SSD striped RAID 10, with parity, is going to be 1,000 times slower than RAM. So first option should be try to get everything in RAM. You're still going to have disk activity. Get the fastest disk you can, but your bottleneck on the SQL side is always going to be disk. That's the slowest part of any computing infrastructure. So, like I said before, you can solve a lot of problems with really fast database hardware, really fast disks, and lots of memory. But if we're troubleshooting the database hardware, some things to look at. You want to look at your average disk queue length for disks, the disks that have your data and or indexes. So you're looking at one. So average, the queue length is basically how many requests are sitting in queue waiting for the disk to respond. So if you've got more than one, so one would be even one is kind of bad. You don't want any requests in queue. You want them all to flow through the IO of the disk. So one is kind of like anything over one. So if you've got 10 disks and you look at like the logical partition on that, and you see your average disk queue length is 10, you're maxing that thing out. So if you're looking at average disk queue length for disk, it's a little difficult to determine, but usually if customers having a problem, we look at average disk queue length, and I've seen like, it's bouncing between 2 and 10,000. We're disk bound. Probably they're configured RAID 5 or something like something inefficient like that, RAID 5 or RAID 6, and they probably do not have 5,000 drives. So that's what you want to look for. Is just kind of a high number there.
Eric?
Yeah. So your memory. Oh, yep.
We've
Laura?
got a question on disks.
Okay.
The question is, will virtual disks scale the same way as physical disks regarding performance?
No. Nope. And so virtual disks are, well, it's a tough question because virtual disks can be made up of separate physical disks. But in general, a virtual disk is slices out of like a single physical disk partition. So virtual disks are not as good as physical. So, but saying that, all my SQL boxes, or our big SQL box, is all virtual disk, but I put that basically on its own physical disk partition. So there's not much else using those physical disks. And so most people have to use physical disks, or virtual disks, but if you can get them on their own physical partition, that's the magic sauce.
Okay, it looks like there's possibly some follow-on questions here. Let me take a quick look. Okay, does the same hold for separating data and indexes on separate disks? No gains or some gains?
Yeah, if you get them on separate disks, you're going to have if you're kind of disk, if your disks are holding you back, if you look at your disk and you got kind of high average disk queue lengths, or high use percentages, pulling those indexes and putting them on a separate disk partition will dramatically increase performance, but it has to be a separate physical disk. You can't create, it doesn't do any good to create another virtual disk on the same hardware and stick your indexes on that. You have to get down to that physical disk layer. And if you're on a SAN, you might even have to be on a different LUN, the way that SANs work. So you need to drill down, and if you're working with like an infrastructure team or something, sometimes it can be difficult to figure out what's going on behind the scenes. Like they might give you more disk for your indexes, but if it's sitting on the same physical drives that your data's sitting on, you're not getting any performance gains. So if you really need to architect that with your infrastructure team and say, we need to get these indexes onto different physical disks, because what happens when you insert or update a record is that the physical disk is writing the record and also the indexes, and they're parallel. They happen at the same time. So if you've got 10 indexes on a table and it's updating the table, it's got to update those 10 indexes also. And so the problem is the transaction can't complete until all those indexes are written and the table is updated. And if they're all in the same physical disk, that's a lot of writes potentially. So if you can get those separated, even better. And then SQL has rollback segments or transaction logs. Those also are being written, and they're used for restore. So if your transaction log should also be on different physical disk. Then check your memory.
Eric, I got a couple other questions that came in. Let's jump in just in case they're related. In hosted scenarios, is virtual typically on top of virtual server / disk configuration for maximum performance? Or will they probably need to be prompted to look at the database resources for a given environment?
You're going to have to get them to look at it. They're not going to do it. The problem is going to different physical disks is expensive. So if you're hosted either with Cherwell or you've got a hosting provider providing hosting infrastructure for you, they're going to do it as cheap as possible. So they're going to max out the resources that they've got, the hardware resources. So you need to get like a physical diagram from them, because probably you can say, well, put my indexes somewhere else, and they're just going to there's no guarantee that they're going to go on different physical. So 9 times out of 10, they're not going to do it right. So you'd really need to drill down with hosting to find out what they're doing.
Perfect, thanks. I think you're safe to move on.
Okay. Database hardware, look at your memory. Is your memory larger than your database? If not, consider adding more RAM. I mean, that's best case. You might get a little pushback for that, but seriously, SQL Server will use as much memory as you give it, basically. And the more memory you give it, the faster it's going to be. The more it can cache the database in memory and do lazy writes and things out to the disk, you're really going to see performance increases. And check your CPU. Is your CPU maxed out? If so, add more CPU. You can fix a lot of problems by adding more CPU. High CPU in a database environment, though, I will say high CPU is always because of bad queries. So, but CPU is pretty cheap, and it's time intensive in things to go troubleshoot these queries. So I'm going to give you some easy things to do, but if you're looking at your database server and the CPU is maxed out, see if you can get a couple more, because if your CPU is maxed out, it's probably doing complex hash joins and things on tables and pulling results out, and it's just really CPU intensive. So I mean, obviously we can lower CPU a lot by using proper indexing and fixing queries, but simple solution is just to add more CPU. All right, so let's talk a little about application tuning. Probably you Cherwell admins are probably already know all this stuff, but just in case you don't, we'll go over it. So the performance of Cherwell is almost 100% dependent on the underlying database performance. But there's a few tailoring things I'm going to go over to watch out for, and give you a few best practice guidelines on creating queries. So typically queries are where we're going to see our performance hit, right? We're not typically going to see on an insert or an update really bad performance. And if you do see bad performance on an insert on an update, it's almost always related to a query being done post insert or update, like in a screen redraw. So queries is where we're going to spend our time. You can almost ignore insert and update guidelines for performance. In fact, I'll talk about it a little bit later, but anything insert and update, I'm normally not concerned about. We're just going to look at queries and all the select stuff. So the first tab. So let's talk about the first tab. So in Cherwell, records will generally load pretty fast by themselves. So if you just pull up an incident in Cherwell, it doesn't have any related records on it, I mean, it's going to pull up fast. It's just basically contained in a single object. You're probably selecting it based on some keyed query. It's going to come back pretty quick. But whatever's on that first tab is also going to load right away. And if it's a bunch of related records, it will slow down the loading of that record. So make sure on the first tab you don't have your journal. Don't stick that in your first tab. And any related items like tasks or other records. So anything where you've got to pull back a long list of records, like I think one of my partners, Bill, was just telling me that he pulled up a service or CI or something, and they had every single outage that ever happened on that service was also pulled back, and it was always timing out. Well, there were hundreds or thousands of potential outages over years and years on this service, and it was coming up as related. So when you're pulling back that related information, that's what's going to slow you down. So make sure that stuff isn't on your first tab. There's some load options. So use load keys whenever possible for one-to-many relationships. Typically it doesn't matter for one-to-one, but if you've got a one-to-many, you can use the load keys only. That will speed it up because it's just going to pull back your like your pointers basically to the record instead of pulling back everything. And that's got a couple ramifications. For one thing, it can pull the key out of an index that's sorted. And it does not need to go out to the table and do a record ID lookup to pull the data in. And also your payload is going to be a lot smaller. So it's just going to take less time to move that data physically from the SQL Server to your client. So that's a good thing to take a look at.
We've got a couple more that came in, Eric.
Okay.
The first question is, do you have any Cherwell clients using SQL Server 2017, and did you experience any major issues?
I don't know, Tony, I haven't worked with any, but Tony, have you seen SQL 2017? I doubt anyone's using it really. That's pretty new, isn't it?
Yeah, it's fairly new. I don't think that I do. I think everybody is they're pretty stationary where they were, right? I've had some move from like 12 to 14 and things like that, but yeah, I don't know of anybody on 17 yet.
Yeah, I don't either.
Okay. The other one is more of a comment. It said most of our performance issues are with a Windows client launching.
Okay. Well, I'd be curious to know if the web client is also has the same performance issue. But typically, what I see with the Windows client launching is you're launching into a dashboard or some sort of very colorful graph-filled thing that you're launching into, and it does take time. All of those graphs and charts or whatever you've got there have got to load up before the screen is drawn. So typically when people are logging into the system, that's when I'm seeing customers logging into some sort of a dashboard. And those are a lot of queries. A lot of times people are just making their own dashboards with no regard to like query performance. So you can usually, once we look at we'll look at a little bit of the performance tuner tool that Cherwell provides, and we can usually figure out pretty quickly the performance issue with those dashboards. And almost always you can speed that up by tuning those queries that are on those dashboards.
Okay, I don't see anything else yet, so
all right,
go ahead, carry on.
So another thing we've got is don't load when constraints are blank. So if you check that for any custom relationships you've created, that's a good thing recommended by Cherwell to do for performance. And one idea for journals, because journal has a lot of information, you might find that it loads slowly. So it's possible to split that thing into two relationships. So keep the current journal relationship and then create like an audit. So for audit information. So maybe you'll just keep journal for information entered by the technicians, something like that, or maybe information entered by the techs and maybe information entered by the user if they're updating the journal, but everything else can go into a different table. That can speed up, if you've got, especially like in modules like change or problem, where maybe you've got a problem ticket that's been open for a year with 1,000 different things you've done to it, and it might have a really large journal, so you'll see that, hey, pulling this up takes a lot of time. So sometimes splitting that out can be a good idea if you find that your journals are really large. That's another fairly easy thing to do to speed up record retrieval. And here's some guidelines for creating good queries. So there's really not outside of use fields that are in indexes. So I've had customers publish the indexes that they have on, say, incident, because incident is really commonly queried, and saying, hey, these are the fields that I've got that are indexed. So if you do queries on these fields, they're going to come back fast. So that's an idea. I guess I don't have that in here, but that's to me that's a pretty obvious thing to do. Hey, just if you want fast queries, query on index fields. But a lot of people don't know what those are, but you as an admin can pretty easily find those and publish those for your users. The other thing that's just a general no-no is using not equals. So anytime you use not equals, so if I'm looking for all incident tickets where the status does not equal closed, and that's my query, that is going to kick SQL Server into a full table scan, because you can't index something that doesn't exist, right? So nulls is the same way. If you're looking for all the customers where their phone number is null, that's going to force a full table scan. It's going to have to look at every single record because you can't index null, so it cannot use an index. So it's using a full table scan. So anytime you use not equals, you have to be careful, and null. So you're better off including multiple records with it in instead of not equals. I think I have an example here, right? So here we go. So if you're looking for all the incidents that are not assigned to a specific group or a set of groups, your query is much better to search for all the groups that is in this section of groups. So if, say, you've got 50 groups and you want to exclude 5 of them, instead of doing not equals those 5 groups or even one group, it's better. Now, I know this is kind of a pain because it's a lot more work, but your query is going to be much more efficient if you use the in for all the groups you want to include, where than if you exclude groups. So, if you've got 10,000 incidents, this probably isn't going to be an issue because you can full table scan 10,000 incidents pretty quickly. But you get like 250,000 incidents or 500,000 incidents, this is not equal group 4 is going to take a long time. So even if you've got 100 or 1,000 groups, I mean, there's really no limit or point of diminishing returns where you add something to an in where it can do an equal, because it can use an index. Indexes are sorted, indexes are small, and they're easy to look at. It's going to be orders of magnitudes faster to use, even to search for 1,000 values in something than to search for a 1 not equal. I mean, it's just better practice. So that's something you can tell your people that are creating dashboards and things. If you've got a not equal in there, chances are it's slowing you down. So there is a kind of an exception. If you've got a not equal with an equal, so if you're looking where status is equal to open and group is not equal to group 4, the query optimizer will use the index for the status, and it'll pull all those records out. And then you still have to do a table scan for group, but maybe you've narrowed down your tickets from, say, you have 100,000 incidents and 10,000 of them are open. So maybe you've narrowed down your tickets from 100,000 to 10,000. So it only has to table scan 10,000 records instead of 100,000. But it's still going to be orders of magnitude slower than if you did use an equal and search for specific groups or null. In fact, if you use null searches a lot, you're almost better off defaulting a dummy value into that field instead of null. So if you're constantly searching for, employees that have null phone numbers or something like that, you're better off putting a rule on that field that populates it with something, at least from a searching, because searching for null is still slow. So that's probably the number one performance killer that I see is not equals. Number 2 is using is querying on fields where none of them are indexed. That's also bad, but this is pretty easy for people to understand and fix, and you don't really have to do anything to the database to make it work. It's all from the query side.
Eric, I got a question.
Yep. Okay.
Actually, a couple have popped in. The first one is, how do you structure a condition in Cherwell admin client that will use an IN statement in the database or an in statement?
Oh, well, I think you're just doing group equals this and group equals that and group equals this and group equals that. Yeah, you're not really. I think you'll see when you look at the query behind the scenes that there's probably an in there. Yeah, I don't think you can do like an is in and Cherwell. You're just kind of concatenating equals together. Is that right, Tony?
Yep, that's exactly right.
Okay. Yeah, so you're doing just multiple equals and equals and equals and equals and equals, and then Cherwell it'll either use that or it'll use an in. There's really no difference. The compiler will take both of those and use the same plan for each. So, or the optimizer. The compiler will compile it into something else actually, and then the optimizer will use the same plan for an in versus an equals and. So just equals and equals and equals and.
Okay, I've got 2 that are sort of related, so I'm going to give them to you both together. You can probably cover them at once. The first one is, what about searching for empty field? And the other one is, does null search equal searching for field is empty?
Yeah, yep, empty is null. So yeah, if you're searching for empty, that's a bad search. I mean, if you don't mind waiting, it's okay. And sometimes, I mean, that's just the fact of life, is that you're searching for something that's empty, that doesn't have any information in it. So, but it is going to be slow. So, especially if there's nothing else.
Eric, I'd say keep in mind the context. If you're running it as kind of a one-off to fix the problem that you've found, great. If you're running it constantly on a dashboard when you're starting up your system, then that might you want to rethink that.
Yep. Yeah, it's definitely something that you need to look at and see, how often am I using this and how important is it? You probably don't want it on a dashboard because it's going to be refreshing and running slow whenever I have that dashboard up. So, okay.
A couple more came in. Let me just see
okay.
If they're related.
Okay.
Try to clear out the other ones here. How does Cherwell build an empty date field?
How does Cherwell build an empty date field? I don't know what that means.
I think that they're referring
here,
to the Laura. I think that they're referring to the you know, when you say is the date empty. So because I know that sometimes the dates show up as like 1970 or whatever the Unix initial date is, and sometimes they show up as like 0001. And I know that in the past Cherwell has also had a fix for some of the dates, like a database fix for going and fixing some of those. So I know that it's varied depending upon which version you were in and what the situation was. So I know that's not much of an answer, but
the follow-on was rather how does Cherwell build a query to find a blank date field since SQL dates can't be null, and they're using version 8.2.3.
My guess is they're using that default January 1st, 1970 or whatever they're using for the date. Yeah.
And I'm pretty sure that but by 8.2.3 that they had got that part fixed, because I think the fix for that thing was in 7 or something like that. I remember seeing the document from support. So
yeah, dates are interesting because they're technically not null, but they sort of are. Yeah, dates are the most complex thing in programming because of all the things. But yeah, I don't know. I haven't looked at the query like that, but I'm guessing they're just searching for that root date, which is kind of the feeder date, which everything else is calculated off from seconds usually. So they're probably not looking at null. They're probably looking at a value. So if that's indexed, that's probably going to be quicker, would be my guess.
Okay, so I've got a couple of comments. One is from another customer who says, we have both dates after the update, both empty and null in the same field after upgrading.
Oh, what do you think about that, Tony? So you just run a SQL update to update those?
Yeah, you know, I haven't necessarily, because I've seen null dates too. In the database, and I haven't seen them necessarily cause problems.
Mm-hmm.
I think that there's, and this is not doctrine, but in my anecdotal experience of all of this stuff, it seems like if you touch a date, then it will populate it. Like if you there's something that it did at some point that I recall, and it was kind of like it was null until a certain point, and then even if you didn't put a value in there, if you kind of were touching something around it or something, then it would put that other date. It was kind of like when it needed it, it would put it in there so that it didn't error out. But if you didn't ever use that or you didn't need it, then it was just kind of ignoring it. So yeah, I mean, again, the dates, I haven't sat down and conducted experiments to understand what the date time is working. I just kind of know that sometimes I need to be very careful when I'm doing those date things to make sure that I am getting back what I think I'm getting back, right?
All right, well, we got a bunch of people on here, so I'll be curious to see if anybody else has run into that, if it's caused any issues or if they fixed it. So maybe they
Okay, one more question before you move on to how would I find out what the null date is?
I don't know if you have an idea, Tony.
I was going to say maybe you could just do a pop-up, you know, I mean, have a date time field and pop up. But usually when I do that, those values come back blank, or they come back with that null date field, and I'm thinking that it's that 1971. So, but I would just do like a pop-up in a one-step pointing to a field that you know is empty, or that, and kind of experiment with it that way.
Yeah, if you look at the database, the problem is any tool that you look at that date with, it's going to interpret because it's actually just like a big number is all it is in the database if you looked at the raw data. But even if you look at it with like a SQL query analyzer, it's going to turn it into a date. It's not how it's actually stored. But that will show you like what the date is. Like if it's a seed date, it'll show you like 111 or whatever that seed date is. So SQL Query Analyzer is your best bet to see what the raw data is, but it's still not even, it's still an interpreted value of what SQL Server stores in the back end. And I hate dates.
Okay, so a couple more follow-on questions here from someone else. It says, so if can be cleared out. I'll let you interpret that question.
If we can clear it out, maybe.
Okay, if you want to retype that question, there's probably a typo in there. The next question is, default empty date in release 9.3.1 is 1899, December 30th.
Nice, okay.
I knew it was a turn of the century.
Okay, so the clarified question is, so the null date can be cleared out? That's the question.
I see, so kind of clearing out that 1890
Yeah, so can
date.
you clear the null date out?
There are some tricks potentially, like you can set up a stored value that's blank and populate the value with that, but that doesn't necessarily mean that the system is going to set it to null. It still might set to that seed date, like Eric was saying. So again, that's more just kind of I think ultimately what this comes down to is where you're not really going to be doing a ton of things from the database perspective. So whether it's null or the seed date is not as important as much as being consistent in the way that you're telling Cherwell how to handle them, because Cherwell is going to be pretty consistent with how it's handling those dates. So I'm not sure I'd be too concerned. I'm not sure I'd be too concerned about whether they were null or the seed date. Just whether or not the system was recognizing whether or not it was, actually populated with a real value or not. So,
but it sounds like that if you null them all out, Cherwell probably would handle it, but it might just repopulate them somewhere down the line.
Exactly.
Like if you're trying to see where the dates were empty from like a reporting tool, and you were checking for null or something, I could see value in that, but you might be better off just figuring out what the date is and looking for that date to see if there's no date, even though there is a date.
Right. Yeah. Look for that seed date. And one little trick you can use is you can put that seed date as a stored value, and then you can compare against that. And then that way you're not always having to type in that seed date or question what that seed date is. So.
Okay.
Are we good on date questions?
I don't think so. Hot topic. So I think we can move ahead.
Okay. Let's talk a little bit about IIS tuning. There's a few things you can do to make sure everything's running as efficiently as possible. So these examples are on 2012 and IIS 8, and it's available for older versions but requires a download. So we want to make the application initialization. You want to make sure that component is checked under application development. So make sure you get that. And then you can change your start mode for each of the application pools in IIS. It's under App Pools Advanced General. Change those to always running. Then they don't fire up when somebody hits them. Make sure those are always running. Change the idle time action for each of the application pools to suspend. So basically instead of when they time out, or they idle timeout, they don't shut down, they'll just suspend, and then they're still active they're suspended, but they're still in memory. Sort of restart that. Those are extremely fast rather than restarting starting the process up from scratch. They're restarted, so that's a handy trick. So if you don't have a lot of activity, maybe at night, so these things don't really matter so much during the day, but maybe for the first few people who are logging in, or if you've got 24/7 and people are on it in the evening, but they don't use it as much, and you're having these processes be shutting down or not running all the time. You might have some wait time as when you fire everything up.
And Eric, one note on that one is sometimes that can be really useful for your Cherwell API. Is if you're making calls, but you're not making them frequently enough, and so it's always shutting down and having to start back up. Sometimes setting that to work with whatever your known integrations are can speed up those integrations. So
that makes a lot of sense, because if you're coming in at once an hour or something and that thing's shutting down and having to restart every hour, they're going to see a big delay. So that will definitely help. That's a good point for the API. Do app init after restart, so set that to true.
Okay, we've got a couple questions on the ISS topic.
Oh, okay.
First one is, are these ISS tunings done for Cherwell hosted users, or do we have to request them?
You probably have to request them. I don't really know how now I did get this from Cherwell, but it wasn't from hosting. So hosting, kind of understand how Cherwell is organized. Their hosting team, isn't really part of like professional services or engineering. They do their best, but I don't know if they necessarily follow these best practices for IAS. So I just don't know. I just haven't had to troubleshoot many hosted performance issues for Cherwell. So, Tony?
Yeah, I'm not familiar. Your best option is to, just open up a quick support ticket and ask them, how that's set up. I'm not really too sure how they delivered the different instances for the hosted customers.
Yeah, I would definitely ask them, see if they'll change it for you.
Okay. Can you see the questions pane, Eric? We have a couple of questions, but I'm not sure the first part of it. I think there's a typo in there. It doesn't make sense to me. Do you want to take a quick look and see if you can figure out what they're asking?
Yeah, I think I see it here.
The last two from Christian.
I can only see one question at a time.
Okay, I'll just read it to you and then you can make sense of it. The question is, does that suspend idle timeout keep from having users to re-log in, or do they still need to log in after being suspended?
Oh, they still need to log in.
Okay.
Yeah, it doesn't really have anything to do with if you're logged in or not. So basically, if you're getting logged out, that's not gonna help.
Okay, move on.
All right, so let's go into the Cherwell health check. So Cherwell does provide this pretty nice utility to troubleshoot performance issues. It can be a little daunting to read through this thing and implement the recommendations. So I think proper procedure would be to implement the recommendations, wait a period of time, a week, and then rerun. So keep that in mind. Like once you implement something, give it a little time to burn in and get newer results, and we'll show you what those results are here, but usually wait a week. I mean, you could do it in a day too, but you're going to get better results if you implement some of the things and then wait about a week and rerun it. SQL Server permissions, make sure you've got the view server state. Without that capability, you'll be unable to view results. and performance will change over time with use as users utilize the system. Although I will say I haven't run a number of these that typically your top 10 or top 20 bad, poorly performing queries, they're pretty much going to be the same if you run it today and then run it for a year from now without doing anything. They're probably going to be the same just because people are using the tool generally consistently day in and day out. So those are still going to be the same. All right, so to run it, you go to the categories and performance and then click run health check and click OK. And it actually kicks you out to an HTML document with a bunch of sections in it. The first section contains general system information and other stats about the run. You can kind of ignore that. It will, where it says check the database at high level for any issues. If there are any issues there, it will say, like I've seen it say things like ad hoc query is turned on, recommend turning it off. So you can ask 2 different SQL experts about ad hoc query results, and one will say, no, it's always got to be on, and the other one will say, no, it should only be on if 30% of your queries are ad hoc queries. So I don't think it makes that big of a difference, but basically that ad hoc query thing I've seen show up a lot. So the table size status, that's the next thing. I don't know why I don't have a screenshot in here, but Cherwell lists the top row counts in the table of the Cherwell system. Are there unused tables? Are there tables that can be cleaned? That's kind of the next thing. I usually just ignore that too.
Eric,
table.
One note on that one. One usefulness that I've seen on that is kind of like if you've got a runaway process that's generating lots and lots of records, sometimes that can be useful. And like, wait a minute, why do I have 50,000 tasks when I've only got 1,000 records? So that can be useful from that perspective. So
that's a good point too. And later on in the presentation, I talk about index recreation and updating statistics. So one of the reasons to update stats frequently is if you have a table that grows and shrinks, like maybe today it has 1,000 records and tomorrow it has 100,000 records. And those are typically transaction tables, maybe incoming transactions, something that are being processed usually and deleted. And sometimes they queue up or there can be, I've seen lots of different reasons, but so that can help identify that too. You can kind of see how the table, like if you're running this health check consistently every week, you can kind of compare table sizes. And if you do see a table that's growing or shrinking rapidly, that is an excellent candidate for statistical updating, so updating stats. I'll talk about that in a little bit later, but as one of the database maintenance things. Caching tables, so that's another thing that comes up, generated from an algorithm which analyzes usage. So you shouldn't cache all the tables that are in this list, but you should look at them. I think this one really works for the Windows client, but the desktop client, I guess. But you should look at some of these that for tables where the data does not change very often, more like lookup tables. If you cache those, you can see performance increases. So this will kind of give you a recommendation based on how often the data in these tables is changing.
And keep in mind that those caching are happening when you're logging in, so that can have an impact. If you've got a lot of cache tables, it'll cache all that when you're logging in and therefore slow down that login process.
Yeah, that's
on
a good
that
point.
note, we've got a question related. It said, will the Cherwell performance be degraded while running a health check, and should it be run during low usage times?
Typically, I have never seen this health check run more than 30 seconds, so I don't think it's a big performance buster. It's basically running some stored procedures that kick out of some SQL system tables some information. So from what I've seen, it runs really fast. I wouldn't worry about running it during the day. Have you ever seen it run slow, Tony?
No, I've had many clients run it during the day in production. I mean,
Yeah.
Certainly the first time, if you're concerned and this is your first time running it, wait till after hours and kind of run a SQL trace on it and make sure everything's, that you're seeing what you expect. But Yeah, I haven't had any problems.
Or just see how long it takes. And it does hit system tables. It doesn't hit Cherwell tables. So it doesn't hit any of your tables that you're doing transactions on, like incident or anything like that. It's almost all system tables. So of course, if you're at peak capacity of your database and everything's slow already, maybe you don't want to run it during, but generally you can run this anytime if it's not going to slow anybody down. So you just evaluate this kind of evaluation of whether you should pull them in or not. So we got some maybes in here and then some probably definitely not. So big tables with lots of data, probably not, just because you're gonna have to pull that thing down when you log in. And some of these are, they're changing, but maybe they don't change very often. So Cherwell says, oh, maybe you can cache these. So, but stuff like SLAs, they rarely change. Your product catalog rarely changes. It's probably not going to change from when you log in to when you log out. Some of those things, service, you probably hit that a lot. You probably don't have a lot, maybe 50 or 100 services. So that's something you might want to cache, so you don't have to look it up every time. And just a quick example on how to cache the table. You just check the little cacheable checkbox on your advanced tab of your business object properties. All right, so more health check results. So the first thing you'll kind of hit after the cacheable tables, the first kind of what I call useful information, is your performance results, worst queries by read. So if you take a look at this, some of the columns, I don't know how well you can see it, but the ones you kind of want to focus on is where the execution count is high. So you can see on this, I've got execution count as your first column. There is a query in here that was executed like 491 times. So that's probably the one you're going to want to focus on, even though your average CPU time is fairly low. If you're looking at like CPU time or read time, any of those, all the numbers, the higher number is generally the worst. But if you've got something that's only run twice, it's not as impactful as something that's run 491 times. So start with those that run that often. And then the query is available in the last column. And you might be asking, well, what do I do? Well, there's not much you can do with this query unless you have access to like the SQL tools. If you have access to the SQL tools, you can take the query, you can pop it into SQL Query Analyzer. Analyzer will give you recommendations for that query to tune it. So you could send it over to your DBA. It's in that very last column over here. It's just you can just copy and paste it. Oop, oop, oop. You can copy and paste it out of the how many times I click out of that last column and send it to your DBA. You can also just look at that query at the where clause and see what columns are in the where clause, and you could try to create indexes like that. And then we'll get to it a little bit later, but there's also recommended indexes that SQL will recommend. You could try to match up the recommended indexes with what's in the where clause in that query. So if you wanted to try to solve that issue, but if something shows up in here and it's got a high execution count, I would definitely have a look at it. So this is by CPU, so we can see some of the executions in here. Like the top one's been executed almost 93,000 times. It's got a fairly low average CPU time, 25,000 for CPU time, so it's a lot lower than some of the other ones. But because it's run so often, you probably want to take a look at that one first. Because it's being run, orders of magnitude more than everything else. So that's where you want to start. If you don't have a lot of time to investigate all of these, look at your execution count where that is high. And then, if you want to get more specific, take your execution time, multiply it by your average CPU time. Just take the largest number out of there, or just look at total CPU time. Take the largest number out of there and start working on those. So your first two columns are kind of, what do I start working on on first, but I usually look at high execution count things first. Okay, so missing index rule, that's kind of the next thing you'll run into. So this is generated by SQL, and it shows the indexes that, hey, if these indexes were here, we'd have a lot better performance. So I do recommend implementing these missing indexes almost always. I almost recommend implementing them all. Sometimes you'll find ones that are really close, and if you run SQL Query Analyzer on, if you trace those indexes back to the queries, which is not super easy. It's not like Oracle. It's not like an Oracle AWR report. If you're familiar with those, you can actually click on the query and it'll actually take you right to what index you should use. So it's not quite as advanced, but it's not that difficult. But in general, I recommend creating the indexes that are recommended here. So this is kind of what it looks like. So you can see it's sorted by total cost. It's got your top 20. So in this example, the first one, total cost is high. It's got 387 index seeks. So it's been run a lot of times. The average user impact, that's out of 100. So it's saying if you created this index, it would improve it like this much out of 100. so if 100 is your baseline for the best or the fastest running, it'll improve at 99.47 out of 100. So basically almost full improvement. So basically on this one, they're saying on your customer table, create an index with customer type ID and SAM account name, and that's gonna solve this issue. So you can see there's no other customer ones. You can see there's lots of incident recommendations. So if we look at, if I'm going to create this index, how do I do it? What order do I put them in? You want to basically put them in the order that you see. Your equality usage is equals. Inequality usage is typically like greater than or possibly not equals. It's something that's not equals. Could be greater than, could be less than, could be not equals, could be something else. But typically you might not know, so it doesn't hurt to put those in your index. So you start with your equalities, kind of put them in the order that they're there, and then add your inequality columns, and then your include columns. Include columns they're not sorted. They're not technically part of the index. They're not used as part of the search, but they're used as part of the retrieve. So if you've got include columns in there, you notice some do and some don't. If they don't have it, chances are, like the first one does not have an include columns, chances are the query is asking for a lot of results, a lot of columns in the result, right? Maybe star, maybe 20 columns, something like that. If you see it, that means that we can do what's called a covering index, which basically covers every column that's requested in the where clause. So we have an inequality, or we have an equality in the second one of customer display name. We have an inequality or status, maybe equals or doesn't. We don't know what it is, so we can put it in the index. Put it second though, and then for include columns, we can put customer rec ID and customer approval email. So that when I see that, I see a query that's saying, select out of incident where customer display name equals something and status equals or doesn't equal or is greater than or something, and also it's doing select customer rec ID, customer approval email, and probably status. So, and it's not selecting any more column. So it's important, if it recommends include columns, stick them in there, because you don't have to go to the table to retrieve that record. It can pull right out of the index, and it is literally 2 to 3 times faster to pull something out of an index than to have to go to the table and pull the record out of the table to give you the data. So it has to do a record ID lookup. It's got to move on the disk. It's just a lot slower, and it's another transaction. It's more disk. So those include columns. The only downside of include columns is that they take up space in your index. So a little more disk, but disk is cheap. So advice from Microsoft: equality columns first, inequality columns next. List include columns in the include clause. They're talking about creating it from SQL, but in Cherwell, you just mark them as include or not. So generally, I tell customers to order them in the order that they are in this missing indexes, but there's some exceptions to the rule. I don't know if I see any in here, but basically, if you have a column that really narrows down your result set first, you want to put that one first. So if you've got, let's say, status and something that wouldn't be like status, you probably have 5 statuses, right? So over 100,000 records, you're going to have, not very many different types of statuses. So status doesn't narrow down your result sets very much, like customer ID would. So maybe a customer has 20 tickets, but there's 1,000 open. So in that case, you would put your customer ID first, which would really narrow down your result set to say 20. And then you would look at only the open ones. So that's the only exception to that rule, is you kind of want to start with your most, get your query the smallest, put that first. So remember that, and adding indexes, that if you already have a field index, that does not mean it will be used in a query. So if I've owned by, if I need to add an index for owned by, and it's already in an index, and the index is in this order: status, open date, and owned by, and my query is owned by equals user 1, the query optimizer will not use that index. It will do a full table scan. It will not use an index. It's horribly inefficient to use a column in an index that's third, because the column is sorted. The index is sorted first by status, and then by open by date, and then by owned by. So it just does not, it will not use that that owned by. So just because you look and say, oh, I've got owned by indexed already, and no, that's not good enough. You need that. If you're searching for owned by, owned by equals user 1, you either need to have owned by itself or first in another index. So if it's first in another index, you're good. Or if it's by itself, you're good. But if it's second or third, second, it maybe use it. Third, it will almost 99.9% of the time not use that index. So you might find yourself creating a lot of indexes, but I think that's okay. So you might ask, won't adding too many indexes affect performance? And I say not really. So additional indexes, they do incur some overhead and DB inserts and updates, but if you recall at the beginning of the presentation, I said I don't really care about insert and update performance, because generally inserts and updates, if you decrease the performance of those, you're usually measuring the decrease in milliseconds. If you're doing a query against a large record set, you're measuring the decrease in performance by minutes, tens of minutes, half an hour. So I say, in theory, yeah, you could have too many indexes, but generally customers that I see, they don't have too many indexes. And you kind of have to weigh the balance between, do I care if this query is slow? Because say I've got 20 indexes already, do I want to add a 21st index? If it'll help the query, but I'll lose 2 milliseconds on my insert or update because now I got another index to add, I say, who cares? Just the query is much more important than your insert update time. The biggest potential downside is that your indexes are going to take up more space in your database. So if you're indexing lots, if you've got 50 indexes on a table, it's not going to be 50 times the space, obviously, but it's going to be more space, a certain percentage of space. So I've seen it's not uncommon for large databases to have more index size than data size for really searchable databases.
Hey, Eric, can I jump in quick?
Yeah. Yep.
So I wanted to let everyone know on the call, we have gone past the top of the hour. If anyone needs to leave, we are recording this session, and within a week, we'll have it uploaded onto our website, and we'll make it available to you. So if anyone does need to drop, you'll be able to see the rest of our presentation at your convenience at a later date. Also, we have a couple questions. Is now a good time to jump in?
Yeah, let's do it.
Okay, I think the first The first one here, I believe you covered, but just in case, I'll ask it anyway. Okay. What about editing existing indexes that already index some or all of the columns on the missing index report? If we index everything recommended, won't that drastically improve write times for fields that are updated frequently?
Yeah, you can. So for the first part of the question, if you've got an index that's close there, as long as, so the big thing with editing existing indexes is you don't want to mess with that first column, because that index is there for a reason and is driven by that first field in the index. So if you're adding fields to the index in the third or fourth or fifth location, or adding some covered columns, that's perfectly fine. So, and like I said, if you have a bunch of indexes on status, or say owned by, and owned by is updated a lot, yes, you'd need to update that index with owned by. Say you have 10 indexes with it, but I'm telling you, it's worth it, because you're talking, like I said, milliseconds of update time. Let's even say it's 2 seconds, which is like 1,000 times more than probably it is. But you're sacrificing the 2-second insert or update time for maybe taking a search from 30 seconds to 5 seconds or 2 seconds. So it's kind of, you do have to weigh that cost, but in my experience, I mean, you really have to add a lot of indexes to notice performance a decrease in updates, because keep in mind, you're probably updating every ticket twice a day. I mean, you're just not doing a lot of updates. So if you do have a highly transactional table where you're doing a lot of transactions on it, yeah, then maybe, if you're updating records, 10,000 records a minute or something, you don't want to have a ton of indexes, but typically those aren't searched very often. So you do have to do that balancing act, but in my experience, just almost ignore any complaints about update and insert. I mean, it's pretty easy to see if it's really bad, but generally the payoff is much higher on the query side than the update insert degradation. Is there more, Laura?
Okay. The other one was, in a hosted situation, we create the indexes within the business object definition. Would all of these equality/inequality fields be best in a single new index, an incident lumping them all together, or should each of these line items be a separate index?
All separate indexes. Yeah, you don't want to lump those together. Indexes are made for specific queries generally. So, and the way indexes work is that they're sorted by field. So it's a sort in a sort in a sort. So, I mean, honestly, you get past 3 or 4 fields in an index, and your result set is already so small. By the time you get 3, 4 fields deep, it's really not even helpful to have past that number. So generally 4, if you're looking at adding more than 4 fields to an index, probably you can stop. I mean, unless you've got huge data sets, probably you can stop at 3 or 4 columns. So you would much rather have, and also having multiple indexes. If you've got one giant index with say 10 or 15 fields in it, that index is going to have to be updated more often because the fields in it are going to need to be updated. So you're updating a larger index, and then there's all sorts of stuff. I mean, I've done day training classes on this, but because of the way indexes work, the B trees and things, the smaller indexes are better.
Okay, free to move on.
Okay, so where should you add them? SQL Server, Cherwell, preferred. If you're hosted, you got to add them from Cherwell. they just won't take your SQL statement and do it, because I know from experience, I've tried. And it's also preferred. Then the Cherwell DBA can see what indexes are added. So Cherwell does not take indexes and create them in Cherwell. It works the other way around. You create the index in Cherwell and it applies in the SQL Server. So if the DBA adds an index, it will not show up in Cherwell. if you're working with the DBA, they may add them from the SQL side. You might not have rights to add. Some companies take away DDL rights for certain things, including indexes from the application login. So you might not have rights. There's no difference from a performance perspective if you're running it from Cherwell or SQL Server. Cherwell is essentially unaware of these indexes at the database. It does not really use them for anything. The database optimizer is using the indexes to create a plan on how it's going to get the data. So it doesn't matter if you add them from Cherwell or SQL from a performance standpoint, but a best practice would be to add them from Cherwell for ongoing maintenance so you can tell what's out there. And Cherwell recommends adding them kind of a couple at a time, but I've added a dozen indexes. I don't know what Cherwell's reasoning behind that is. I've added a dozen or more indexes to a single blueprint and published it without an issue. I mean, it does take some time to build those indexes, but I just don't, I'm not sure what the issue with adding multiple indexes is. So. All right, so let's talk a little about database maintenance. So what indexes versus clustered? Clustered index is actually a table sort by the index column. So if you've got a clustered index, typically they're going to be by rec ID or what the primary key is. It is the most effective index on the table because the data is actually sorted by that index. So there's not actually a physical index for a clustered index. If you look at it, it is just the table. So in your typical index lookup, you'll get the index records, which are just basically pointers to the table, and then you go to the table and look those records up, kind of inefficient, which is why you want those covering columns. In a clustered index, there is no row ID lookup. In fact, if you look at your SQL query analyzer, it will tell you like index scan. And if you see an index scan on a clustered index, it's basically a full table scan. But because it's a clustered index, it sees the whole table as an index. So consider making the most common queries on the table the clustered index. You can change these. So rec ID is the out-of-the-box clustered index on customer. If the majority of your searches are on the customer's phone number, you might want to switch the clustered index to that field. So here's how you do it. You just go into the index in that object, and you find the clustered index, whatever it is. In this case, it's PK customer. Uncheck it, and then you go into the phone index. So you got to have an index for phone, and you check it. And then what this will do is it'll sort all your customer records by phone. And if everybody looks up everybody by phone, it'll be 1,000 times more efficient than looking it up in an index and then going to get the customer record out of the table. So.
And one situation where that might be extra important is if you've got screen pops, depending upon what field it's using to pull up those customers, that might be what you want to put your clustered index on.
Yeah, and you might even see on incident. Generally, lookup tables, the clustered index is most efficient on your rec ID because that's what it's storing when it's looking the record up. But on your core tables, like incident, change, you might want to switch your clustered. Like if you're looking and you're like, geez, everybody is running queries on group and status because everybody wants to see their open tickets. Maybe that should be your clustered index. Group and status, the group it's assigned to, and the status of the ticket. Maybe that should be your clustered index. So you can make that decision. It's not that big of a deal, but it is a lot more efficient to pull data out of a clustered index than a regular index/table. Beware, switching the clustered index can be time consuming, as the entire table must be rewritten in a different order. So if you have 500,000 incidents and you decide you're going to switch your clustered index, keep in mind that it will take a long time because it's rewriting the table. Oh, and nobody can update the table or insert records into it when this is being done. So do it off hours. Small tables generally fast, but so one of the things, index rebuilds, index become fragmented over time. So defragmenting will increase query performance. It's not going to be a dramatic thing because indexes are pretty efficient even when they're fragmented. But overall disk performance and CPU performance, you will see performance gains if you rebuild these indexes. I recommend rebuilding them monthly as a generic standard. If you're looking for how often should I rebuild these indexes, have monthly, because we'll get to that in a sec. Index rebuilds can be done from Cherwell. So that first checkbox there is your business objects indexes. I just rebuild them all. And they're the system table index. System tables aren't as important because they don't have the turnover in data that regular business object indexes do, but I would do them both. Honestly, I just wouldn't do them from here. I'd talk to your DBA, have them set up a package to do it off hours. Keep in mind, rebuilding index is different than a reorg. I like the rebuild because it does stats, but you can't update or insert data into a table when index is being rebuilt. You can during a reorg, but not during a rebuild. So keep that in mind for maintenance. That's why I'd usually tell a DBA to do it, unless you want to get up at 3 in the morning to run this thing. Updating stats. So the stats are used by the query optimizer to come up with the most efficient way to query the data. They are rebuilt automatically during an index rebuild. So if you already do an index rebuild monthly, if your stats are being updated monthly, you're probably good to go. The exception is what I talked about before. If you've got a table that's growing dramatically in a day or two. So, and what happens is the first time you query a table, SQL Server builds a plan on how it's going to get the data. So if you've got 10 records in a table and you're querying on, say, two of the columns, and you're returning the rest of the columns, maybe 20 columns. So you're doing a select star from table where column equals 1 and column equals 2. The query optimizer will say, okay, this query is querying 2 columns but returning 20. It's got 10 records. I'm just going to do a full table scan because I got to get those records out of the table anyway. There's only 10 records. So now and that plan is cached and it's kept in SQL Server's memory, and every time you run that query, it'll bookmark that cache plan. It'll pull it down and reuse it, which is great until you have 100,000 records in that table. So now it's doing a full table scan on 100,000 records because it's not updating the plan. So you can set the tables to update stats automatically. I really recommend doing them during the index rebuild. If you've got tables that are dramatically increasing in size and decreasing in size, I recommend doing them more often. If you've got a table that'll grow from 100 records to 100,000 records in an afternoon, maybe running stats on that thing 4 times a day. Running stats in a single table is pretty fast, and it will redo the downside is it redoes all your cache plans, and the plans have to be redone. But the upside is if you've got a table where data is dramatically changing daily or weekly, your plans will be the most efficient all the time. All right, so I've got some other things in here that I was kind of planning on just skipping, but they could go out with the document if people wanted to request this document, and they're basically things like reviewing logs, checking your schedule, doing some cleanup on your published log, your trebuchet mail table, your processes, are they running and completing? So archiving and purging. But since we're already at an hour and a half, I think we should just open her up to questions and discussion.
Great. So now is the time to put those questions into the questions pane. So feel free to log those. We'll keep the lines open for a few minutes for that. And we'll also move into an open forum Q&A. So if you have things not related to tuning that you'd like to ask Eric or Tony from our team, we'll be happy to take those as well. So far, I'm not seeing any more questions on tuning. So for anyone left on the call, if you have questions not related to tuning, feel free to pop those in, and we'll keep the lines open for as long as you'd like to chat with these two, or at least until the top of the next hour. So a couple of you have asked along the way, are we recording the presentation? So the session, as I mentioned a little bit earlier, is being recorded. We'll make it available. And I'm also happy to share Eric's slide deck from today with everyone on the call. So as soon as I get that from him today or in the next couple of days here, I will work on emailing that out to everyone so that you have all the information available to you, including the last few slides. I'm not seeing any questions yet. If you do have questions, now is the time before we close. We'll leave the line open for a minute or two just to give people time to ask any questions, but I'm getting some feedback that this information is really helpful. So thank you, Eric, for putting this together.
Well, a lot of people stayed on for the whole time, so hopefully it was it was good.
Okay, I do believe one came in. Let me read it here. Regarding the similar items tab, is it better to constrain the base search or remove the tab and expose it in a different way? If editing the search to constrain it better, what recommendations do you have?
I would start with editing the search to constrain it better on tab. See if you can lower that result set. If the result set is high, it's just going to be slow. So if the other way is like what I was talking with Bill the other day is if you've got something like a history on a service and there's just no way around it. We want to be able to see all the history on this service. Maybe do it a different way. Maybe don't put it on a tab, but put it on a be able to launch that from that service. Be able to launch the history so you're not loading it with the record, but you can do it more as a stored query, something that you can look up later. Any of those tabs that you look at and they've got a lot of information in them, they're going to slow down. So if you can get that result set smaller, that's what I'd first look at, just because it's simple. But if you can't, I think in Bill's case, there's just an outlier. Just this service just happened to have a lot of tickets associated with, probably a popular service, a lot of changes probably associated with it. So even if you have an outlier like that, and it takes 5 minutes to pull up or it just times out, you got to do something about it, right? So you can't just have that continue. So you need to figure out something. In that case, it's probably better to launch a query with that information in it.
Yeah, I'll typically do the same thing. Like I'm not too worried about the first tab or whatever. I'm just more worried about the data that it loads and how useful it is to the people that are using it. So typically I'll limit like incidents, similar incidents or incidents for a service for like the last 30 days, the last 60 days or something along those lines is usually what I would recommend on those.
Yeah, it's not a bad idea for that type of historical information. Just drop information that's old, and if you need to see it, go to the incident table and query on it that way instead of pulling it up in the record.
Yeah, you can search against it. The other thing you can do if you're really advanced in terms of user interfaces, you could have a link that says show all versus show first 30 days, and then it can kind of activate based on those expressions that you can do in tabs. So you can have like a tab, one of the tabs that's looking at that value, and then they can kind of come and go, and one can load all and one can load none, or load the 30 days. So
sure.
Yeah, you can get creative with that kind of stuff.
Okay, we do have some more questions that are trickling in, so let's keep moving along. What about the portal and gaining efficiencies? Outside of ISS recommendations, any specific recommendations for the portal? Ours seems to go down frequently and needs an app pool, recycle to restore. Nothing in logs, in CPU and memory is fine.
Well, as far as performance, I mean, the portal just uses the standard database. So when you're troubleshooting performance, we're just going to be looking at the database. Now, if that thing is crashing, now that's a whole different story. Have you seen the portal crash much, Tony, in implementations?
I haven't, but it's kind of interesting because I was talking to one of our other coworkers, and they were indicating that they had a client that their portal was crashing, and I kind of said, well, it's not usually there's not really anything that Cherwell does from a portal perspective. I mean, it gets delivered from IIS. Normally, it restarts on its own. So if it's actually like not recovering and you're having to go in and screw with the app pools and some of the other things, then there's probably something going on in the actual IIS settings that's causing problems. But I don't see that. I've never seen that, and I've only heard of it just recently. So there's always the potential that in a newer version there is something odd going on, because I don't have all of the information, just the stuff that I've experienced. So yeah, and if there's nothing in the log file on the IIS, that's a little odd too, because you would expect, I don't know if that's just looking at the log files as they are, or if you've actually got some resources available to help understand if the log files are actually turned on in a correct way to capture what is needed. So.
Okay. The next one has a couple follow-on pieces, so bear with me while I read through it all. Where do we draw the line on what's acceptable for time it takes to load records, or to stop blaming Cherwell and start looking at infrastructure? What would you recommend on troubleshooting with remote users? We're hosted. It makes it tough trying to get Cherwell, myself, and the user together since we're in different time zones.
Yeah, the thing on where do you draw the line for performance, I mean, I always tell people, if it's taking longer than 1 or 2 seconds to load, say, an incident or a change, I mean, that's kind of a long time in database world, right? So I don't know, whatever you think is too long, but if you're looking at 2 or 3 seconds to load a record, to me, that's fixable. You know, you should be able to load a record fast. Now, hosted with remote users, you've also got your network payload to keep in mind. So you got kind of your database, but what you really need to do is compare, you know, from a known, like if everybody at the office is running fast, but somebody remote is running slow, well, chances are they've got some network issue where it's just taking a long time to transfer that data from the host site to them, like a network slowdown. But yeah, it's an interesting question. How long is too long? In my mind, I mean, honestly, it shouldn't even take a second to load a record. But I know because of the relationships and things that people put on their forms, it does. Now, dashboards are a whole different story. You know, I've seen dashboards take 30 seconds and people are totally happy with it. So typically, I mean, you're looking at 2 to 3 seconds per query if they're optimized on a dashboard. So if you've got 5 or 6 things, say 6 things, at 3 seconds, maybe 18 seconds would be something to shoot for. On the, like, if it's slow, I mean, these queries, your query shouldn't run more than 2 or 3 seconds each. If you got 5 of them or 6 of them, I mean, 30 seconds is too long for like a dashboard.
He says the remote user is in the UK.
Oh, well, that's a whole ocean he's got to go over to get his data back from. So chances are you're looking at chances are that pipe is probably pretty full going to the UK from the US. That, you know, they string cable under the ocean, I think, that connect these continents together. So yeah, I mean, you can get pretty deep. You can hook up like packet sniffers up to a machine to see how big the packet is that's coming across, the payload that's coming across. You know, potentially you could have super fast, efficient queries on your related records, but if you've got, say, a journal that's coming back really fast, but it's got, you know, people are copying and pasting emails into that thing, so it's quite large, well, that is going to take a long time to transfer that payload from Colorado to the UK if you're hosted. So that's, my guess is that's probably the issue, is that if you like used Wireshark or something to grab that payload, it's probably going to be pretty big.
Okay. We have one more question here. To limit results in tabs, do you have to constrain the relationship or just a limit on the tab criteria?
Tony?
Yeah, I was just thinking, do I know the answer to that question? I don't think I know definitively. I do know that early on in the days of those filters that there was some that it was loading all of the records, and therefore the filter was only like when I enacted the filter, it would show up and I could get all the records to show. So that kind of indicates to me that it's bringing back things and kind of tossing them during that process. So from an efficiency standpoint, I would say if you can do it from the relationship first. And then, but I don't know how those filters are actually being implemented, and they may have changed the way that they were implemented in newer versions. So, but my personal preference is to always go at as foundational of a level as I possibly can get for any change. Obviously, in some cases where you're using that relationship for other things, where you might need things beyond those dates, then you're going to have to kind of balance that out. And nothing says that you can't have two relationships either, one that contains all of them and one that contains just 30 days. And as long as they're not set to load immediately and you're not loading it on the first tab, then you should be able to kind of leverage those two relationships based on what you're needing. So.
Okay, a couple more just came in. One is actually a comment. It's a note regarding system maintenance. This person says the Cherwell scheduler can schedule/run the system maintenance after hours. Wouldn't necessarily need the DBA to schedule it. It's just another option.
Yeah. If you can schedule from Cherwell, you might as well you can do that also.
Okay. The last question I have here is, does the don't use not equal rule for queries apply to constraints in relationships as well?
I would say yes. I mean, again, you're not always going to be able to avoid those situations, but those constraints are the definitions for for queries that are run. So if you open up the system analyzer when you're loading, say, like an incident record, it will show all of the related all the related records that it's loading and how much time it took. So that's going to play directly into those. So long answer for short yes.
Yeah, that's a good point. I didn't even bring up System Analyzer, but that's a pretty good tool to see what's taking so long to load. I mean, it's kind of not for the layperson to look at, and because there's a lot of information in there usually, but I've used it numerous times for different things. Very, very helpful.
Okay. I don't see any other questions. So with that, I'm going to conclude. If you think of questions after the fact and you'd like to visit one-on-one with Stratacom, please reach out to us at any time. I'll follow up with everyone from this presentation and give you the slide deck, and you'll have my contact info there. So reach out to me if you'd like to visit with us further, if we can help you with it. With that, we hope you'll join us on future advanced practitioner calls. Have a great rest of your day, everyone, and thank you to Tony and Eric.
Thanks, you guys. Have a good day.